Hey, everybody. I hope you're all doing well. Um, I am managing at home. I'm starting to go a little stir crazy. Today is actually my first official day by myself because everybody else has gone back to school and work. So I'm left with my puppies. They're keeping me company, but I sure do miss you all a lot. Um, and I want to apologize if they start barking because they are barking at everything that goes by the window. Anyway, let's go on and get started with this video. Today we're going to be working with mixed problems, is what I call them, where we're going to be going all over the place on the double mole diagram. So make sure you have your double mole diagram out, and you also have your periodic table out and a calculator. Let's look at our first example. Again, I will give you the balanced equations so you don't have to worry about them. And the question is, what volume of carbon dioxide measured at STP, so standard temperature and pressure, which means we can use our double mole diagram, will be produced when 80 grams of calcium carbonate reacts? So in my first example, I broke it down in the 3 steps. So if we look at our double mole diagram here, again, formula units is sometimes used in place of your number of particles, atoms, or molecules. So if you want to add formula units for A and formula units here to B down here at the bottom of your double mole diagram, you're more than welcome to. So what I mean by being mixed problems is that we've gone and did the bridge with the 1 step. Then we went a step further and we went from mass of A to mole of A, mole of A to mole of B, mole of B to mass of B. Now, with this particular problem, we are going to start with mass because we're given 80 grams. So we're going to go mass of A to mole of A, mole of A to mole of B. And then we're going to jump up here to our volume using our 22.4 liters in our problem. So if we look back at our notes, what are we trying to find and what are our given? So we're given 80 grams. That's going to be your A on the double mole diagram, substance A. And what we're trying to find would be our volume or liters of CO2. That would be our B on the double mole diagram. So we start with what we're trying to find equals what we're given. So we're given 80 grams of calcium carbonate. We go to our periodic table, find our molar mass of calcium carbonate. And so if we look at our mole diagram, we're going mass to moles. So that means moles will end up being on top of our equality. And since the substances are the same, this will be a 1 mole here. And now we've converted to our moles of calcium carbonate or moles of A. We take our answer, if you like the 1-step problems, and we're going to convert our moles of calcium carbonate. So we're here at A to moles of B. So we put moles of calcium carbonate at the bottom and moles of our new substance, or B, or CO2, what we're trying to find, in the top. And we go to our equations coefficient. So we have the coefficient of 1 for calcium carbonate, the coefficient of 1 for carbon dioxide. So this case, we're using both 1s for our equality. Your moles of calcium carbonate cancels out. We're at moles of carbon dioxide. Now we're going to convert our moles of carbon dioxide over to liters. So we're here at moles of B, and we're going to go to volume of B, or moles of CO2 to volume of CO2. So if we want moles of CO2 to cancel, it goes in the bottom of our equality. Liters of CO2 will go in the top, and we use 22.4 because that is what we use as we go from moles up to liters. So the moles cancel of CO2, and we're in liters of CO2, which is what we're trying to find. I prefer to do the 1 3-step problem instead of the 3 1-step problems. Whichever way you prefer to set them up, that is fine. So again, we're given 80 grams of calcium carbonate. If we want grams of calcium carbonate to cancel, they go in the bottom. Moles of calcium carbonate goes in the top. So mass to moles. Now we're going to go moles of A to moles of B. So moles of calcium carbonate will go in the bottom, so they cancel out, and moles of CO2 will go in the top. Remember, the 1 mole of calcium carbonate is right here because they are the same substance. This middle step here, your moles may be a different number other than 1. It depends on what your balanced equation is showing. So again, they're showing 1 and 1. Now, we're sitting here at moles of CO2 or moles of B, and we're going to go to volume or liters of B or CO2. So if we want moles of CO2 to cancel, that goes in the bottom, and your volume or your liters of CO2 will go in the top. Multiply everything on top, multiply everything on the bottom, divide that answer. That's where you get the 18 liters of CO2 from. Let's take a look at our next example. So we're working with the same balanced equation again. We want to know how many molecules of carbon dioxide will be produced if we are starting with 80 grams of calcium carbonate. So the first part of this problem is going to be worked out just like our last one. So we're given 80 grams of calcium carbonate. We're finding our molecules of CO2. So we're going to go mass of A to moles of A, moles of A to moles of B. This is what's different, our last step. We're going to go moles of B to number of particles or atoms or formula units, and we use Avogadro's number. That's what's going to be different with this example. So I'm going to go a little faster. So we'll go mass of calcium carbonate. Again, this came from using the total amount of calcium, carbon, and 3 oxygen adds up to 100 grams. So your grams of CaCO3 cancels were to moles of CaCO3. Then we're going to take our moles of CaCO3 and we're going to go moles to CO2. So our moles are canceling out here, and we use our equation coefficient. Take your number of moles of CO2, and this is our new moles of B to number of particles of B. So we're going to go and use our moles of CO2 will go on the bottom and cancel. We use our number of particles, 6.02 times 10 to the 23rd molecules, and we get our answer finally. Like I said, I prefer to do the 3-step problem, okay? So let's go on and work an example out together. This time we're working with a totally different practice problem, and I want to know what is the mass of ammonium chloride if we are working with 2.8 liters. Oh, wait, no, that's our product. So I want to know how many grams of ammonium chloride will be needed if we make 2.8 liters of ammonia, NH3, at standard temperature and pressure. Okay, so I've been kind of messing around with this, and hopefully my handwriting will be clear that you'll be able to read and follow along as I'm writing. Okay, so let's write our given and our find. So we are given 2.8 liters of NH3, ammonia. And we are going to, and let's see, this is going to be substance A on your double mole diagram. And our find is going to be the mass. So how many grams of NH4 Cl? So we're always going to start with our find. So we're going to go question mark grams of NH4Cl. That's going to equal what we're given, or A. This is substance B. Our find is substance B. So we are given 2.8 liters of NH3. We're going to make our equality. If we want the liters of NH3 to cancel, it has to go in the bottom. So let's take a look at our mole diagram. We are right here at liters, so we're going to go liters to moles. So moles of NH3 will go in the top. And since NH3 is in the top and bottom of our equality, we'll use the 1 mole, and we use the 22.4 liters because that's what's showing in our diagram. Remember, liters and decimeters cubed are the same thing. You did a great job with that. So that means that your liters of NH3 cancels. We're now to moles. Now we're going to go moles of A to moles of B. So if we want moles of NH3 to cancel, that will go in the bottom. And moles of B will go in the top, which is NH4Cl. And we're going to go to our equation here. So we have the 2 for the NH4Cl and the 2 here for the NH3. Okay. So now we are going to convert moles of B down to, to our mass over here. So moles of B over to our mass. So we want moles in the bottom, so it cancels out. And this is moles of NH4. And we're going to our mass of NH4. So I'll put grams of NH4 in the top. So in this equality, since it's the same substance on top and bottom, we're going to put a 1 for our number of moles, and we go to our periodic table and determine the mass of 1 nitrogen, 4 hydrogen, and 1 chlorine, and that will be 53 grams. So now we're going to multiply everything on top. So we're going to have 2.8 times 1 times 2 times 53. And that ends up being 296.8. And we're going to multiply everything on bottom. So 22.4 times 2 times 1, that's 44.8. Divide those two out and you'll get your final answer of 6.6 grams of NH4CO. So kind of draw that out just a little bit so that way you can see all of the work. So again, we're going to go from liters of NH3 to moles, moles of NH3 to moles of ammonium chloride, then moles of ammonium chloride to your mass of ammonium chloride. Again, this middle step where you have your two different substances, this is where your number of moles may be different, and you go to your balanced equation to look at your equation coefficients. That's where your 2's came from. One other thing I wanted to just caution you of, watch for your diatomics. You've been doing a great job of if it's H2 or O2 with your masses. Now there are, again, some elements like one of your problems you had phosphorus, which has a mass of 31, but if you looked at the formula, it was P4. So you want to make sure that you multiply 31 times 4 to give you the total mass of all four of those phosphorus atoms.